The universe breathes in silence. Beneath the glow of distant galaxies, space stretches without boundary, a vast canvas painted with cold fire. The human eye, fragile and curious, looks upward and wonders where it all ends. Yet the more we search, the more the cosmos responds with quiet contradiction. It has no edge, it has no center, it has no final line to cross. The deeper the gaze, the more reality unfolds, not as a single world, but as a suggestion of many and endless layering of possible existences. Infinity is not a number. It is an idea that refuses to stop growing. Every thought of limit dissolves before it. The mind tries to imagine the end of the universe, but in that instant, it imagines something beyond the end, and infinity begins again. To live in such a place is to exist inside a question that never finishes asking itself. What if reality is larger than the universe we see? What if existence continues beyond every horizon, repeating itself in variations that can never be counted? The stars are the first invitation to think this way. Each one burns with its own story, born from dust, gravity, and time. Yet there are more stars than the mind can grasp. The light we see tonight may have left its source before the Earth even existed. If so much can be born from one universe, what could lie beyond it? The thought trembles at the edge of understanding. It is here that imagination reaches its most dangerous point, where wonder begins to challenge the structure of reality itself. Space does not whisper in words, but in patterns. Radiation hums through the void. Matter bends around invisible fields. Quantum fluctuations tremble inside the smallest pockets of nothing. These vibrations, though silent, speak of possibility. They tell us that emptiness is never truly empty, that every point of space is alive with potential, waiting for the right conditions to give birth again.
Travelers.
In such a reality, one universe may not be enough. Creation may not be a single act, but a rhythm, a pulse that repeats endlessly across different realities. Imagine a realm where light has never been born, where gravity moves differently, where time folds inward instead of stretching forward. These are not fantasies, but consequences of mathematics when it refuses to stop at one universe. If the rules of existence can vary, then countless versions of reality could coexist, each sealed within its own horizon. Some may look similar to ours, others completely alien, obeying laws no human could survive within. Yet each would be real in its own frame, a truth unto itself. The scale of such thought is difficult to hold. The human mind was shaped for survival, not for infinity. It seeks pattern, familiarity, cause and effect. But the cosmos answers in riddles that ignore simplicity. Every discovery, every equation, every telescope image stretches the boundary of what seems possible. And still the question grows, is this vast universe the only one? Or are there others, invisible and unreachable, breathing quietly beyond our perception? To imagine infinity is to stand at the edge of reason. It is to watch everything known fall away into the dark and still continue looking. There is something both terrifying and sacred in that act. The unknown becomes a mirror, showing the smallness of human certainty against the endless expanse of what might be. Yet even in that smallness, there is wonder. The awareness of infinity gives weight to the present, because every moment becomes unique against an ocean of endless possibilities. The night sky has always offered two lessons: how small we are and how vast we belong to. Each photon that reaches our eyes has crossed unimaginable distances, carrying the memory of stars that may no longer exist. They remind us that even in isolation, we are connected to something greater, not just by matter or light, but by the very fabric of possibility that binds all existence together. Perhaps infinity is not a distant concept. Perhaps it lives within every atom, every decision, every thought. Every vibration of energy may echo through dimensions unseen, branching into realities that we cannot sense but that still unfold in parallel. In that view, the universe is not a single story, but a library without walls, where each page gives rise to 1,000 others, and no reader ever reaches the end. The whisper of infinity does not call for understanding. It invites surrender, a quiet acceptance that reality may be far more vast, strange and beautiful than anything the mind can fully grasp. To hear that whisper is to remember that existence itself is a mystery still unfolding, one that may never be contained by any single world, or even by the concept of a universe. Every great mystery begins not with certainty, but with a question. The idea that our universe could be one among many did not appear from myth or imagination alone. It emerged from science, from minds that dared to see beyond the visible horizon of space and time. Long before telescopes captured galaxies, before equations described space-time, thinkers wondered whether the cosmos might be more complex than what human eyes could see. Yet it was not until the 20th century that the idea began to find its shape in the language of physics. The story begins in the aftermath of discovery. When Edwin Hubble looked through the Great Hooker telescope in the 1920 seconds, he noticed something astonishing. Distant galaxies were racing away from each other. Space itself was expanding. This realization shattered the notion of a static universe. If space was growing, then at some point in the past, it must have been smaller, so small in fact, that everything once fit into a single dense point. From this came the theory of the Big Bang, but even as it explained our cosmic origins, it raised deeper questions. What lay beyond that initial explosion? What existed before the universe began? The early universe was not a simple explosion of matter into empty space. It was an expansion of space itself, a transformation of nothing into something. The laws of physics emerged with it, shaping energy into matter, matter into stars, and stars into life. Yet for scientists like Alexander Friedmann and Georges Lemaitre, who studied Einstein's equations, the mathematics did not confine the universe to one form. Their equations allowed for endless variations, universes with different curvatures, densities, and fates. Some could expand forever, others collapse back into themselves, and some might never have been born at all. Within the mathematics of relativity, the seed of the multiverse already stirred. Still, it would take quantum mechanics to give that seed form. In the 1920 seconds and 30 seconds, physicists began to uncover the strange behavior of particles at the smallest scales. Reality at the quantum level was unpredictable. A particle could exist in several states at once, a blur of possibilities waiting for observation to define it. This discovery broke open the door between what was real and what was potential. The world was no longer a fixed clockwork, but a spectrum of possible realities. Each event, each measurement, each choice hinted at other outcomes, other paths the universe might have taken. The word multiverse had not yet entered the vocabulary of science, but its shadow already stretched across the early theories of cosmology. Every attempt to explain why the universe is the way it is seemed to lead to another question. Why this universe and not another? Why these laws, these constants, this balance that allows stars and life to exist? The precise tuning of reality felt almost deliberate, yet randomness alone seemed insufficient. If there were countless universes, each with its own rules, then the existence of one that supports life would not be surprising, it would be inevitable. As the century advanced, new minds entered the mystery. Alan Guth, a young physicist in the late 1970 seconds, sought to explain why the universe looks so uniform. His idea of cosmic inflation proposed that, in its first fraction of a second, the universe expanded exponentially faster than the speed of light. This rapid expansion could smooth out irregularities and explain the cosmos we see today. But it carried an unexpected consequence. If inflation could happen once, it could happen again endlessly, in regions beyond our own. Each expansion could give birth to a new bubble universe, disconnected and unreachable. With that, the multiverse took its first true scientific breath. The birth of the idea was not a single moment, but a slow awakening. It grew from the mathematics of relativity, from the paradoxes of quantum mechanics, and from the search for cosmic origins. Scientists did not set out to imagine infinite worlds. They were simply following logic to its limits. And when those limits dissolved, what remained was possibility. The human imagination had always dreamed of other worlds. Ancient philosophers speculated about parallel heavens, mirrored earths, and endless cycles of creation. But now, for the first time, physics itself began to whisper the same story. The multiverse was no longer myth. It was the natural consequence of equations that refused to end with one universe. To think of many universes is to rethink existence itself. The birth of the idea marked a turning point, the moment humanity began to realize that its home in the cosmos might not be unique. Each discovery since then has carried the echo of that revelation. The multiverse was not born in fantasy. It was born in the pursuit of truth, one question at a time, until the very notion of everything expanded beyond recognition. Reality, when examined closely enough, begins to tremble. Beneath the stillness of matter and the predictability of motion lies a hidden dance of uncertainty. What appears solid is nothing more than probability woven into form. It was in the quiet laboratories and chalk-dusted rooms of early 20th century physics that this trembling first revealed itself, and with it came a realization that would alter our understanding of existence forever. The quantum world does not behave as the human mind expects. In the visible realm, a ball thrown through the air follows a precise path, determined by force and angle. But in the subatomic world, such clarity vanishes. Electrons do not orbit the nucleus like planets circling a sundae. They shimmer in clouds of possibility, existing everywhere and nowhere until something observes them. This was not speculation but measurement, an unavoidable truth discovered through experiment. Werner Heisenberg's uncertainty principle defined the limits of knowledge itself. One could never know both a particle's position and momentum at the same time. The act of measurement changed what was being measured. From this paradox emerged one of the most haunting images in science: Schrödinger's cat. In this thought experiment, a cat sealed in a box with a radioactive atom would be both alive and dead until someone looked inside. Though absurd, it captured the heart of quantum behavior. Until observation, every outcome exists simultaneously, suspended in superposition. The world, at its foundation, is not definite. It is a haze of potential realities, each waiting for consciousness or interaction to decide which will become true. This revelation caused a quiet quake through physics. Reality was no longer a single line of events unfolding with certainty, but a collection of probabilities branching at every moment. If a particle could exist in multiple states at once, could not an entire universe exist in multiple states as well? The smallest particles of existence began to hint at something vast, that the universe itself might be a kind of wave function, containing infinite versions of its own story. Quantum mechanics revealed that the universe is not deterministic. Even if one knew all the laws of nature and every particle's state, the future could not be predicted with precision. There is always a roll of the cosmic dice, a flicker of uncertainty that cannot be erased. That flicker is not chaos, it is the birthplace of possibility. Each event, each atomic transition, carries within it an entire landscape of potential outcomes. In that landscape, some physicists began to see something far more profound than randomness, the faint outline of many realities. When the first experiments confirmed quantum superposition and entanglement, the classical image of a single, objective universe began to dissolve. Two particles could remain linked across light years, influencing one another instantly, as if the universe itself ignored its own speed limits. Albert Einstein called it spooky action at a distance, a phrase both skeptical and poetic. But it was real. The cosmos was connected in ways that defied space, hinting at a deeper structure of existence that operated beyond human intuition. In this new world, observation was no longer passive. To look was to alter, to measure was to create. The universe did not exist fully formed, waiting to be discovered. It unfolded through interaction. Each observation collapsed a wave of possibilities into one outcome. Yet what of the other outcomes? Did they vanish? Or did they continue elsewhere, untouched by our perception? The question, simple yet staggering, became a fissure through which a new understanding of reality would emerge. The quantum shiver is more than a physical phenomenon. It is a philosophical tremor that shakes the foundation of what it means to exist. If reality can exist in many forms at once, then the world we know may be only one expression of something infinitely branching. Every event could be a choice, every choice a fork in the structure of being. The laws of probability might weave entire universes from the smallest uncertainties. Some thinkers resisted the implications. To them, quantum mechanics was only a mathematical tool, not a statement about multiple realities. But others looked deeper. If nature did not decide between possibilities, Perhaps all possibilities occur each within its own domain, invisible to the others. From this daring thought, the seed of the multiverse gained a new dimension. The universe, seen through quantum eyes, might be a fractal of endless branching worlds, all born from the trembling of subatomic particles. The quantum world humbles every assumption about permanence. It reveals that solidity is illusion, that even the most stable atom is a storm of probability. Within that storm, existence ceaselessly reinvents itself, flickering between what is and what might be. The universe, vast as it seems, may only be one frame in an infinite sequence of realities, each trembling into being from the same quantum breath. The quantum shiver is the pulse of creation itself, a vibration so small it cannot be touched, yet powerful enough to shape everything that is. From it rises a truth that challenges all certainty. The universe is not fixed. It is alive with possibility, forever branching, forever becoming. The story of our universe begins not with stillness, but with a sudden, unimaginable expansion. In the first fraction of a second after time began, space itself is believed to have surged outward with impossible speed, faster than light, faster than thought, faster than any motion the laws of physics would normally permit. This idea, known as cosmic inflation, emerged not from fantasy, but from the pursuit of answers to puzzles that refused to leave cosmologists in peace. By the late 1972, scientists had already accepted that the universe was expanding, but when they looked closely, something did not add up. The cosmic microwave background, the faint radiation left behind from the Big Bang, appeared astonishingly uniform. No matter where the telescopes pointed, the temperature was nearly identical across the sky. Yet, according to standard Big Bang theory, distant regions of the universe should never have been in contact. There had not been enough time for light, or anything else, to carry information between them. So how had they become so evenly balanced? Into this mystery stepped a young physicist named Alan Guth. He was searching for a way to explain why the early universe behaved so smoothly when it should have been chaotic. One night in 1979, while scribbling through equations in his notebook, he found the key, an idea he called inflation. Instead of a steady expansion, the universe may have undergone an extremely rapid swelling, increasing its size by an enormous factor in less than a trillionth of a second. Like air rushing into a balloon, this burst of growth could stretch space so quickly that any initial irregularities would smooth out. The horizon problem, the flatness problem, the uniformity, all of it could be explained. Inflation was more than just a mathematical patch. It changed the way scientists imagined the beginning of everything. In this new vision, the Big Bang was not the start of space and time, but rather a transition, a moment when inflation slowed and energy condensed into matter. What we see as our universe might be only one pocket within a much larger structure, a single bubble where inflation happened to stop. In other regions, inflation could still be raging, endlessly creating new universes beyond our reach. This realization was both elegant and unsettling. Inflation could explain the cosmos we observe, yet it also implied something far stranger, that the process never truly ends. If inflation is a property of space itself, then once it begins, it can continue forever in some parts of the universe. While one region cools and stabilizes into galaxies and stars, another continues to expand, giving birth to more bubbles, more universes. Each would carry its own version of physical laws, its own constants, its own potential for life. The universe, in this picture, is not a single entity, but an eternal, self-replicating field of creation. The mathematics behind this idea are formidable, yet the concept is simple at its heart. Inflation begins with a field of energy pervading space. As this field decays, it releases a tremendous burst of energy, the Big Bang, within each bubble. But the decay is uneven. Some regions transition quickly, forming stable universes like ours. Others linger in the inflating phase, expanding exponentially and spawning more bubbles in the process. The result is a cosmic foam, each bubble a universe unto itself, expanding in silence, forever separate from its siblings. This concept, sometimes called eternal inflation, turned the question of origins inside out. There may be no singular beginning, no single Big Bang, Instead, creation is ongoing, distributed across a limitless expanse of inflating space. Our universe, with its galaxies and laws, is one flicker in an infinite chain of cosmic births. Every instant, new universes could be forming, their horizons receding into dimensions we will never touch. For the first time, the multiverse became a natural consequence of physics, not a philosophical speculation. Inflation predicted not only the structure we observe, but also an invisible reality beyond. It offered a mechanism for generating infinity itself. The vastness of existence, once confined to imagination, began to emerge from equations written in the language of quantum fields. This vision carries a strange beauty. It suggests that creation is not a singular miracle, but a constant rhythm. Every burst of inflation is a heartbeat in the infinite body of the cosmos. The energy that shaped our universe is still alive somewhere, pushing outward, forming new skies, new times, new beginnings. The universe, it seems, does not simply exist, it continues to become. Yet with this insight comes humility. If inflation is correct, then everything we can see, every galaxy, every star, every thought, is only a small region within a vast and endless sea. Our observable universe becomes a speck, floating in an ocean of unseen worlds. The true cosmos might be too large to ever comprehend, too infinite to ever measure. Inflation began as a solution to a simple problem, but it opened the door to something grander, a universe without borders, a reality that renews itself forever. In the silence of space, far beyond the reach of any telescope, new worlds may be swelling into being right now, untouched, unseen, and yet born from the same spark that ignited our own. The universe does not stand still. It swells and breathes, its fabric stretching quietly in every direction. Galaxies drift apart not because they move through space, but because space itself is expanding beneath them. The further they are, the faster they recede, carried away by the unseen tide of cosmic growth. For centuries, this motion puzzled and humbled observers. Yet modern cosmology now tells a deeper story, one where expansion is not merely a phase, but an unending process, a creation that never stops creating. When Alan Guth first proposed inflation, he solved several mysteries but unintentionally opened a far greater one. The equations describing that first burst of expansion refused to settle down. They suggested that, under certain conditions, inflation never truly ends. While it stops in some regions, forming universes like ours, it continues elsewhere without pause. This is the concept of eternal inflation, a cosmos that grows not as a single bubble, but as an infinite froth of universes, each born from the energy of the last. In this vision, the universe is not a singular entity, but a process, a self-replicating field of creation. Space, driven by the strange pressure of inflationary energy, expands at incredible rates, while quantum fluctuations cause certain regions to slow, cool, and crystallize into separate universes. Each pocket stabilizes into its own reality, sealed off from the rest by the relentless stretching of space. Communication between them becomes impossible. What happens in one remains forever hidden from another, like raindrops scattering on an endless window pane. The scale of this expansion defies human comprehension. In every instant, entire universes are born not metaphorically, but as a literal consequence of physics. Each one contains its own version of time, its own chemistry, its own gravitational balance. Some may collapse seconds after forming, never giving rise to stars. Others may evolve for billions of years, nurturing galaxies and life. From the outside, there is no boundary marking where one ends and another begins. The multiverse expands like a living organism, growing from the energy of its own infinite potential. The mathematics of eternal inflation point to a reality that is restless. Once the inflationary field begins, it decays unevenly. The regions that decay slowest continue to grow the fastest. Their volume multiplies endlessly, even as other regions stabilize into finished universes. The result is paradoxical. While some universes cease expanding, the total volume of inflating space always increases. In other words, creation outpaces completion. There is never an end to new beginnings. This picture carries profound implications for the nature of time. In an eternally expanding multiverse, there is no first universe and no last. Each birth is local, not absolute. The arrow of time, which moves forward within any given universe, becomes a relative direction rather than a universal truth. Somewhere, even as this moment passes, other universes may be beginning their own histories, while others already lie in their final darkness. The cosmos becomes a living mosaic of creation and conclusion, all happening simultaneously within an infinite field. To the human mind, raised on the idea of a single cosmic timeline, this endlessness feels unreal, yet it aligns with the logic of energy and entropy. The inflationary field is a wellspring of potential, always on the verge of transformation. It cannot rest, because rest would mean perfection, and perfection would mean an end to motion. Instead, existence seems built to expand, to evolve, to generate. From one spark emerges a chain reaction that cannot extinguish itself, a cosmic fire that continually forges new realities from its own heat. This eternal growth blurs the distinction between creation and existence. There is no singular act of genesis, no single moment when everything began. Instead, creation is constant, woven into the structure of reality. Our own universe, immense as it seems, may be just one thread in an endless tapestry, a transient wave cresting briefly before merging back into the infinite sea of space. The concept also redefines isolation. Each universe, though sealed by the speed of its own expansion, is part of the same greater whole. They are not separate islands drifting apart, but ripples in one infinite ocean of space-time. From this perspective, every birth of a universe is another way the cosmos experiences itself, another melody in the eternal song of creation. No universe is more central than another. All are equal expressions of the same boundless energy. The eternal expansion transforms the question of why there is something rather than nothing. Nothingness, it seems, is unstable. The vacuum, left to itself, becomes pregnant with possibility. From the smallest fluctuation, energy blooms, space swells, and time begins anew. The universe exists because existence cannot help but generate itself. The very emptiness of reality is fertile, forever giving rise to more. To imagine eternity in motion is to glimpse the deeper character of existence, dynamic, self-sustaining, without conclusion. It is not a creation that happened once, but one that happens always. Every particle of light, every wave of gravity, every breath of time is a continuation of that first expansion, still echoing across an infinite horizon. The eternal expansion humbles all notions of finality. It reveals that even as our universe drifts toward eventual stillness, the act of creation continues elsewhere. Reality is not closing, it is unfolding, eternally, into the endless. Infinity is not only vast, it is repetitive. The human imagination often envisions infinity as endless diversity, but true infinity contains something more haunting: the return of the familiar. In an infinite cosmos, every configuration of matter, every pattern of energy, every possible arrangement of atoms will eventually reappear. It is not a poetic metaphor. It is the quiet mathematics of existence when space and time stretch without limit. Consider the stars that fill the night sky. There are roughly 10 billion trillion in the observable universe, yet this number, colossal as it sounds, is still finite. Beyond the horizon of observation, if space continues endlessly, then there must be more, an uncountable expanse of galaxies repeating across eternity. In such a landscape, every possible combination of particles will occur not once, but infinitely many times. Somewhere, far beyond what any telescope can reach, there could exist another Earth, identical in every detail, another ocean reflecting another moon, another you, breathing the same air, reading the same words, unaware that countless versions of you are doing the same, scattered across the endless repetition of cosmic possibility. This idea is not fantasy born from fiction, but a natural implication of infinity. In a boundless universe governed by physical laws, the number of ways particles can arrange themselves is limited, even if immense. Once those possibilities are exhausted, repetition becomes inevitable. Given infinite space, patterns recur not just approximately, but exactly. The universe, therefore, is not a singular event, but a repeating structure, echoing itself without end. At first, the notion feels mechanical, like an endless reel of identical film frames. But within that repetition lies something profound. Each duplicate world is both familiar and new. Slight variations branch from every quantum uncertainty, every flicker of choice, creating an intricate network of similar yet distinct universes. Infinity becomes not a flat repetition, but a living architecture where every possibility not only occurs but persists. Imagine standing at the edge of an infinite plane covered in mirrors, each reflecting another version of the same landscape. Some images are perfect, others slightly altered by invisible distortions. As the reflections stretch beyond sight, the difference between them grows. Yet no matter how far you look, the essence repeats. The cosmos may operate in the same way. Each region of space might be a reflection of another, shifted by random fluctuations, yet built from the same underlying physics. This idea gives new meaning to identity. If countless versions of you exist, what makes this one distinct? Perhaps it is not difference that defines existence, but awareness. You experience this particular version of reality, this thread in the infinite weave. The others remain forever beyond reach, though they may exist in perfect parallel. In the mathematics of eternity, individuality becomes a kind of local illusion, a momentary separation from the repeating whole. Yet repetition is not without beauty. It ensures that no creation, no moment, no consciousness is ever truly lost. Every configuration that can exist will exist, again and again. The stars that die in one universe will shine anew in another. Civilizations that vanish will rise elsewhere, their stories retold in endless variations. Even the deepest silence of space hums with the echo of recurrence. The cosmos, in its infinite scale, forgets nothing. In the vast architecture of repetition, chance itself loses meaning. What we call probability may be only perspective, the local view of one branch among countless duplicates. Every possible outcome of every event plays out somewhere. To toss a coin is to divide reality into heads and tails, both realized, both continuing. The familiar uncertainty of life becomes part of a grander pattern, the perpetual unfolding of all possibilities within an infinite frame. There is, however, a quiet melancholy in such thought. If everything repeats, does novelty still exist? Perhaps what feels new is simply new to this version of us, in this particular branch of infinity. Each awareness experiences its own beginning, unaware that it is one of endless echoes. Yet meaning is not diminished by repetition, it is deepened. Every instance of life, even if duplicated infinitely, is still unique within its own perception. The experience of being, of knowing, feeling, wondering is real wherever it occurs. Infinity does not erase significance, it multiplies it. The repetition of universes also hints at a strange symmetry between life and death. If every configuration returns, then death too is temporary within the grand pattern. Somewhere, in the endless lattice of reality, another version of you awakens, continues, remembers differently. Existence, seen through infinity, becomes cyclical, a vast recurrence of forms, moments, and consciousness, all connected through the shared rhythm of eternal becoming. In this view, creation is not a single event in the distant past. It is an ongoing recurrence that never began and will never end. The cosmos endlessly remakes itself, weaving the same patterns in infinite combinations. The night sky, though it seems unique to our eyes, may have appeared in countless skies before. Every photon of starlight that reaches us might carry the same story retold across boundless time. The infinite repetition is both terrifying and consoling. It speaks of a reality where nothing is ever truly lost, where every dream, every possibility, every fragment of being finds expression somewhere in the endless. To exist within it is to be part of a pattern that never fades, a single pulse in the eternal heartbeat of creation. Every symmetry hides a secret. In the language of physics, symmetry is not just beauty but law, the quiet principle that preserves balance across creation. Yet some symmetries seem incomplete. For every motion forward, there should be a reflection backward. For every charge, an opposite. For every universe that expands, perhaps one that contracts. Out of this longing for perfect balance arises one of the most haunting ideas in cosmology, the existence of mirror universes. The notion begins with a simple question. If nature loves symmetry, why does our universe appear so asymmetric? At the birth of the cosmos, equal amounts of matter and antimatter should have formed. Yet somehow, matter prevailed. The imbalance allowed galaxies, stars, and life to exist. But where did the antimatter go? Some physicists began to wonder if the missing half of creation did not vanish at all if it resides in a parallel realm, invisible but gravitationally near. This is the essence of the mirror universe, a reflection of our own cosmos, built not of ordinary matter, but of its opposite. Every electron there could correspond to a positron here, every galaxy a countergalaxy of inverted charge and reversed spin. The two realms would rarely interact, separated by a kind of invisible membrane, yet subtly influencing each other through gravity. Our universe could, in theory, have a ghostly twin, unseen, unlit, but moving in tandem with us through the ocean of space-time. Beyond the symmetry of matter and antimatter lies another, deeper mirror, time itself. Physicists have long noticed that most of nature's laws are time-symmetric. The equations of motion do not distinguish past from future, but the cosmos does. Entropy increases, stars burn, lives move forward. Why? If time's arrow points one way in our universe, could it point the opposite way in another? Some theoretical models suggest exactly that. In these visions, the Big Bang was not a single explosion, but a mirror event. From the same origin, two universes emerged, one moving forward in time, the other backward. To us, their time runs in reverse. To them, ours does. Each perceives itself as moving naturally forward, unaware of the other's reversed flow. The two universes balance each other perfectly, maintaining the overall symmetry of creation. What we call the beginning might, for another cosmos, be the end. This mirror time concept, though abstract, carries an almost poetic precision. It offers an answer to why the universe began with low entropy. In a dual-time creation, the symmetry of opposites restores equilibrium. One universe expands while the other contracts. One grows older as the other grows younger. The totality of existence remains timeless, balanced between its own reflections. There is also the possibility of a mirror geometry universes made not of opposite matter or reverse time, but inverted space. In certain models of string theory and brane cosmology, our universe could be a membrane floating in a higher dimensional space. Parallel membranes might hover close by, invisible yet real. If one of those membranes were a mirror of ours, its properties could be inverted. Left becomes right, positive becomes negative, curvature reverses. These universes could drift side by side, separated by only a microscopic gap in extra dimensions, their presence detectable only through gravitational influence. This concept gives new meaning to the unseen forces that haunt our observations. Dark matter, which outweighs visible matter 5-1, might be composed of particles from a mirror sector. They would pass through our world unnoticed, yet their gravity would tug on galaxies, shaping their motion. In this way, the invisible could be the reflection of ourselves, a cosmic symmetry hiding just beyond the reach of light. The idea of mirror universes is not confined to theory alone. It emerges naturally from the search for consistency in physics. Every imbalance demands correction. Every broken symmetry whispers of something unseen restoring the balance. The universe, elegant and precise, rarely leaves its equations half-finished. If matter exists here, its counterpart may exist elsewhere. If our time moves forward, another's may rewind. Contemplating such mirrors alters the very notion of reality. What we see may be only one face of a larger whole. Beyond every horizon could lie an inverse world, completing the symmetry of creation. Perhaps when one universe darkens, its reflection brightens. Perhaps every action, every fluctuation, finds its opposite echo beyond the veil. In this grand balance, nothing stands alone. The mirror universe is not a mere reflection of matter, it is a reflection of meaning. It suggests that existence requires duality, that the cosmos is built from tension between opposites. Just as light defines darkness, motion defines stillness, and life defines death, perhaps our universe defines its twin, each giving the other purpose. If such a mirror exists, It does not contradict the beauty of our own world, it completes it. The balance of opposites may be the deepest law of all. The cosmos might not simply expand outward, but inward toward its reflection, forever striving for the symmetry that birthed it. In the end, the idea of mirror universes reveals something timeless about the nature of understanding. For every truth we discover, there may exist its opposite, unseen, yet equally real. Perhaps that is why the universe appears so mysterious, because every revelation we uncover is only half of the whole. Reality, when viewed through the lens of quantum mechanics, becomes a forest of possibilities. Each event, each decision, each flicker of chance is a branching point where existence divides. The world we experience is only one path among countless others, each unfolding simultaneously in its own domain. This is the essence of the many worlds interpretation, a theory that dares to say everything that can happen does happen. The roots of this idea trace back to the mid-20th century, to a young physicist named Hugh Everett III. At the time, quantum mechanics had already revolutionized science, yet it carried with it an unsettling paradox. When a particle is unobserved, it exists in a superposition of many states, its properties undefined. But once it is observed, the superposition collapses, forcing the particle into a single outcome. The act of measurement seemed to shape reality itself. For many physicists, this collapse was a mystery that could not be avoided. For Everett, it was unnecessary. He proposed something far more radical. The wave function never collapses. All outcomes occur, but in separate branches of the universe. In Everett's vision, every quantum event splits reality. When a photon travels through a double slit, it doesn't choose one path, it takes both, in two diverging worlds. When a particle spins up or down, both results exist, each in its own branch of the universal wave function. Even human choices participate in this branching. Every decision you make divides existence into countless versions, each following a different consequence. One you turns left, another right. One speaks, another stays silent. To each, reality feels whole, yet both are real, continuing unaware of one another. This interpretation removed the mystery of collapse but replaced it with something far more profound. The universe, according to Everett, is a constantly dividing organism. It does not evolve linearly but multiplies endlessly, each moment giving birth to new realities. These branches are not separated by space, but by quantum state, each isolated, unable to communicate, yet all equally valid. In this picture, the multiverse is not an additional hypothesis. It is the natural outcome of quantum law taken literally. The implications are staggering. If every possibility is realized somewhere, then randomness becomes illusion. Probability is not about what happens, but where the observer finds themselves within the branching. When we flip a coin, we do not watch chance decide the outcome. We divide into two observers, one seeing heads, the other tails. Each branch feels complete, unaware of the other. What we call the future is simply the set of all branches that flow from the present, each carrying its own version of history. This branching universe challenges every human sense of identity. If infinite versions of oneself exist, what does individuality mean? Perhaps the self is not a singular entity, but a wave of potentialities that continually divides. Consciousness, in this view, becomes a traveler along one path of many, aware only of its own unfolding. Every life, every choice, every dream that could have been is not lost. It continues, somewhere, with its own continuity of experience. The universe becomes a library of lives, all written simultaneously, none erased. Though Everett's theory was met with skepticism in his time, it has grown quietly in influence. It preserves the mathematics of quantum mechanics without invoking collapse or observation as special events. More importantly, it restores consistency. The universe does not behave differently when watched, it simply divides. What we call observation is merely participation, the observer entangled with what is observed, joining the branch that matches their experience. The elegance of this theory lies in its symmetry. Every outcome exists, every possibility realized. Yet, because the branches cannot interact, each remains unaware of the infinite others. The universe we perceive feels unique only because it is isolated by decoherence, the quantum process that prevents overlapping realities from blending. Like ripples spreading on a pond, each branch expands independently, carrying forward its own history into eternity. To imagine this is to envision reality not as a single river, but as a delta, a vast system of diverging streams, each born from the same source. Time does not flow in one direction, it blossoms outward. Every moment is a new divergence, a fork where existence multiplies. The totality of these branches is the true universe, a boundless, ever-expanding tree of being, where every possibility is realized and nothing is wasted. There is a quiet poetry in this vision. It suggests that no path is lost, no life truly unlived. Every regret, every missed opportunity, every unspoken word finds its echo somewhere in the infinite branching of reality. The universe, in its quantum depth, is infinitely generous. It gives birth to all that can be, refusing to discard even the smallest potential. Yet, the many worlds interpretation also carries a subtle melancholy. It implies that each consciousness is forever confined to its branch, unable to glimpse the others. The infinite versions of ourselves remain distant, like reflections in a shattered mirror. We sense the vastness of what could be but can never reach across to touch it. The universe, it seems, is both infinite and solitary. Still, within that solitude lies wonder. Every choice, every fluctuation, every breath adds another leaf to the branching tree of existence. The quantum universe does not end, it proliferates, endlessly creating new realities with every moment. In its silent mathematical elegance, it tells a story of eternal becoming a reality that does not decide between possibilities, but embraces them all. At the frontier of modern physics, where the equations of gravity meet the hidden dimensions of quantum theory, lies a vision of the cosmos so vast that even infinity seems crowded. This is the cosmic landscape, a realm predicted by string theory, where the laws of physics themselves are not fixed but fluid, varying from one universe to another across a boundless terrain of possibilities. String theory began as an attempt to unify the forces of nature. It imagines that all matter and energy are made not of point-like particles, but of tiny vibrating strings, their frequencies determining the properties of the universe. One vibration becomes an electron, another a photon, another perhaps a graviton, the particle of gravity itself. Yet the theory, elegant as it is, brought with it an unexpected consequence. For the mathematics to work, the universe must contain not 4 dimensions, but 10 or even 11. 6 or 7 of these are hidden, curled up in geometric patterns too small to see. The shape of those hidden dimensions determines the laws of physics that emerge in each universe. Like an instrument tuned in countless ways, each configuration of dimensions gives rise to a different cosmos, with its own constants, its own particles, its own version of reality. The number of possible configurations is not small. It may reach 10 to the power of 500, or even more. Each represents a unique universe within a near-infinite landscape of potential worlds. This landscape is not a literal terrain of hills and valleys, but a mathematical one. Each valley represents a stable state of the universe, a possible set of laws where space, time, and energy settle into balance. The question then is why our universe occupies this particular valley. Why do we have these specific constants that allow stars and life to exist, rather than others where everything collapses or evaporates? The answer, according to some interpretations, may lie in the vastness of the landscape itself. Out of countless possibilities, some universes must simply permit existence as we know it. We live in one of those because only such universes allow observers to arise at all. In this view, the universe is not unique but one expression among unthinkably many. Each pocket of the multiverse could explore a different combination of physical laws. Gravity might be stronger in one, weaker in another. Some universes might have no atoms, no light, no time, as we understand it. Others might operate with entirely different forms of matter, producing structures and realities that defy human imagination. The landscape, in its immensity, becomes a cosmic field of experiments, a place where nature tries every possibility, endlessly. To grasp the scale of this concept, imagine an infinite field stretching beyond comprehension, dotted with valleys of stability. Inflationary expansion, like a rolling wave, sweeps across this field. Each time it slows, it falls into a different valley, creating a new universe with its own unique laws. Some valleys are shallow, leading to short-lived worlds. Others are deep, forming long-lasting universes like ours. But the process never stops. Inflation continues elsewhere, generating more and more pockets of reality, each a different expression of the same underlying theory. The cosmic landscape transforms the very idea of physical law. What we consider fundamental constants, the speed of light, the strength of gravity, the charge of the electron, may not be universal truths, but local conditions, like the temperature of a single climate zone within a vast planetary system. Each universe in the multiverse may be governed by its own version of physics, and we, as observers, live in the one that allows consciousness to exist. This idea, though immense, carries an almost delicate elegance. It suggests that existence itself is a spectrum, not a singular fact. The universe is not fine-tuned for life. Life simply emerges where the tuning happens to allow it. The improbable becomes inevitable when repeated infinitely. What seems miraculous, the precise balance of forces that permit galaxies and biology, becomes natural in a cosmos that tries every combination. The landscape is also a meditation on potentiality. Every point represents not just an alternate set of numbers, but an alternate form of being. Somewhere, perhaps, exists a universe without light, where gravity pulls inward so fiercely that even atoms cannot exist. Somewhere else, time might flow differently, or space could fold into strange geometries where cause and effect lose meaning. And perhaps, among those universes, others have their own kind of awareness, consciousness formed from unfamiliar matter, gazing upward toward alien skies and wondering, as we do, if they are alone. Yet for all its grandeur, the cosmic landscape humbles as much as it inspires. It reminds us that the universe we inhabit is a local expression of something infinitely greater. Our laws, our constants, even our sense of reality may be temporary footholds in a boundless expanse of possibility. Science, in attempting to describe everything, may have discovered that everything is too vast to be singular. The cosmic landscape is not a map we can traverse, but a framework for thinking about existence. It reveals a reality where creation is not confined to one event, one law, or one truth. The multiverse becomes a living field, its universes blooming like flowers across an infinite mathematical meadow. Each is complete within itself, yet together they form the totality of being a cosmic garden without edges, where even the laws of nature evolve, forever branching into new forms of reality. Reality feels three-dimensional because our senses were shaped within it. We move through space left and right, up and down, forward and back, and we drift through time, one second following another in an unbroken flow. Yet physics whispers that there may be far more to existence than we perceive. Hidden dimensions, unseen yet fundamental, could be folded within the fabric of space itself, forming a silent architecture beneath everything we know. The multiverse, if it exists, may hide behind this dimensional veil. The idea of extra dimensions first appeared not in imagination, but in the quiet logic of mathematics. When Einstein unified space and time into space-time, he revealed that gravity is not a force, but a curvature matter, bending geometry. Soon after, a new question arose. What if the geometry of the universe has more directions than we can sense? In 1919, the physicist Theodore Kaluza proposed that adding just one extra dimension could elegantly combine gravity and electromagnetism into a single framework. His idea was revolutionary but invisible. The additional dimension, he suggested, must be curled up so tightly that no experiment could detect it. Decades later, as quantum theory deepened, this idea returned in grander form through string theory. To make its equations consistent, the theory required not 4 dimensions, but 10 or even 11. These extra dimensions are not empty extensions of space, but intricate shapes, compact, folded geometries known as Calabi-Yau manifolds. Within these hidden forms, the vibrations of strings determine the fundamental properties of our world. The pitch of those vibrations defines particles, forces, and even the possibility of life. The structure of reality, then, may depend on the shape of dimensions we can never see. If higher dimensions exist, they could be closer than we think. Imagine our universe as a sheet of paper floating in a wider space, a brain, short for membrane. Everything we know, every atom and photon, is trapped on this sheet, unable to move beyond its surface. Gravity, however, might not be confined. It could leak across dimensions, linking our brain with others that hover nearby. Each of those could be a separate universe, parallel yet invisible, just a fraction of a millimeter away in a direction we cannot point to. The gap between them is not distance as we know it, but dimensional difference, the veil between worlds. This concept, known as brain cosmology, reshapes the question of the multiverse. The universes are not scattered across an infinite void. They coexist within the same higher dimensional space, stacked like pages in a book whose depth we cannot perceive. Occasionally, the pages may ripple or collide. Such a collision, some physicists suggest, could release a burst of energy powerful enough to create a Big Bang, not the first, but one of many. Our universe could be the aftermath of such an impact, born from the trembling of higher dimensions. Hidden dimensions may also explain why gravity appears so weak compared to other forces. If part of gravity's influence seeps into extra dimensions, it would dilute across the higher space, leaving only a faint residue within our own. This idea has inspired experiments designed to test whether gravity deviates from Newton's law at microscopic scales. If it weakens faster than expected, it could hint that the force is escaping into unseen realms, a sign that the dimensional veil truly exists. To visualize these concepts is to stretch imagination beyond ordinary space. One can picture an ant walking along a tightrope. To the ant, the rope seems like a line, a one-dimensional path. Yet, from a distance, we see its full shape a cylinder with hidden directions. Likewise, our universe may seem three-dimensional from within, while higher beings or broader physics might reveal its true form as multidimensional. We are the ants on the cosmic rope, moving through the dimensions available to us, unaware of the hidden directions that fold around our reality. The existence of extra dimensions also transforms our understanding of identity and locality. If the universe is one layer in a stack of many, what defines here? Every point in our space might have corresponding points in neighboring dimensions, invisible counterparts vibrating in harmony or discord. Reality could be a grand resonance of overlapping spaces, each contributing its own note to the cosmic symphony. Our universe might be only one melody and a chord far richer than human senses can hear. Yet, for all its elegance, the dimensional veil remains elusive. We cannot yet open it, cannot peer beyond it, cannot prove that it hides other worlds. But its logic persists, because it offers coherence, a way to unite the smallest and the largest, the quantum and the cosmic. It allows gravity to speak the same language as light, matter, and time. It offers a stage vast enough to contain not only one universe but all possible universes. The beauty of the idea lies in its quiet implication. The unknown may not be far away. The boundary between this world and the next might pass not beyond galaxies but through every point of space, folded within each particle, humming invisibly beneath the structure of matter itself. The dimensional veil is not a wall, it is a fabric, and through that fabric, countless universes may be woven parallel, interlaced, and forever just beyond our reach. The birth of a universe may not have been a singular explosion, but a collision, a meeting of vast, invisible worlds drifting through higher dimensions. In this vision, the Big Bang was not the beginning of everything, but an event within something far larger. The trembling impact of two cosmic membranes, or brains, striking each other in the silent void beyond perception. From that impact, space ignited, time began to flow, and our universe came alive with light. This idea arises from string theory's extension into M theory, which adds another dimension to the picture of reality. Within this framework, our universe exists as a three-dimensional brain floating in a higher dimensional space called the bulk. The bulk is not empty. It is a vast arena containing other brains, each with its own potential to host a universe. These membranes can drift, ripple, and even collide. When they do, the energy released can be immense enough to ignite the creation of a new cosmos, a fire born not from nothing, but from motion in a deeper reality. Imagine two vast sheets, invisible and silent, gliding toward one another through a dimension beyond our own. For untold ages they drift, separate, their surfaces smooth and unbroken. Then, slowly, gravity pulls them together. The moment of contact releases an ocean of energy, a burst of light and heat that expands outward, not into space, but creating space itself. That expansion becomes what we call the Big Bang. The brains rebound, perhaps drifting apart again, leaving behind a newborn universe glowing with the memory of collision. This vision, known as the ekpyrotic model, reimagines the beginning of time as cyclical rather than singular. The Greek word ekpyrosis means conflagration, a term used by ancient philosophers to describe the periodic destruction and rebirth of the cosmos. In this modern counterpart, universes are not one-time miracles but repeating consequences of the deeper motion of brains. As they move, they may approach and collide again, giving rise to new bursts of creation. Time, in this model, stretches not from a single point, but through infinite cycles of impact and renewal. The concept finds subtle hints in the patterns of the cosmic microwave background, the ancient light that fills the universe. Some cosmologists have searched for faint irregularities, signs of prior universes or collisions imprinted in the earliest radiation. Though evidence remains uncertain, the idea itself persists because it fits a deep intuition in physics, that beginnings rarely arise from nothing, and that even creation follows the rhythm of continuity. In the brain collision model, dimensions themselves are dynamic. The bulk, the higher dimensional space where brains drift, is not static. It vibrates, undulates, and responds to energy within it. The collisions between brains are not accidents but part of a cosmic dance, a choreography of higher geometry. Each collision releases the potential stored in the geometry of space, translating abstract dimensions into tangible reality. The Big Bang, then, becomes not an explosion of matter, but a transformation of energy across dimensions. This model also offers an elegant answer to one of cosmology's deepest puzzles: why the universe looks so uniform on large scales. If our cosmos emerged from a collision between brains, the shockwave would have spread evenly across space, smoothing out irregularities. The energy released in every direction would set the stage for a universe balanced and coherent. The same process could repeat, with each new impact creating a slightly different universe, tuned by the conditions of its collision, different constants, different structures, different possibilities. To imagine such a process is to see creation not as a single dawn, but as a cosmic heartbeat. Each pulse is a collision, each rebound a new era of existence. Between collisions, universes expand, age, and fade into stillness. When the brains meet again, time restarts. The multiverse, in this vision, is a living organism breathing, contracting, expanding, never at rest. Our universe is one inhalation in that infinite respiration. There is a quiet poetry in this vision of cosmic renewal. It suggests that destruction and creation are not opposites, but partners in the same eternal rhythm. When universes burn out, their energy does not vanish. It folds back into the higher dimensional bulk, fueling the next collision, the next beginning. Nothing is truly lost. It is only transformed. The multiverse becomes a perpetual rebirth, a cycle with no first or final act. From a philosophical view, this model touches something ancient in the human mind, the yearning to believe that endings are never absolute. The stars we see tonight may be the ashes of earlier universes, their light carried forward into new space. Our existence could be the echo of countless previous creations, each leaving subtle imprints upon the next. Time itself may be layered, each epoch built upon the memory of another, like rings in an unseen tree growing through dimensions. Yet, as with all grand ideas, the brain collision remains a hypothesis, its evidence indirect and incomplete. Still, it endures because it resonates with the logic of nature that energy seeks balance, that motion breeds creation, that existence is never truly still. If it is true, then somewhere in the higher dimensional expanse, other brains may already be moving, their collision imminent, preparing to give birth to new universes beyond imagination. The brain collision reminds us that our cosmos may not be isolated or final. It may be one of endless ripples spreading through the fabric of a deeper dimension. The Big Bang, once thought to be the first moment of everything, might only be the latest breath of a multiverse eternally stirring behind the veil. If the universe is a building, its blueprint may be written in layers. Each layer reveals a different level of reality, structured not by walls or matter, but by the logic of mathematics itself. The physicist Max Tegmark once proposed that the multiverse can be organized into levels, each representing a deeper kind of existence. His idea is not merely a hierarchy of worlds, but an architecture of being a map that traces the path from the physical to the abstract, from what we see to what might underlie all possible realities. The first level of this architecture begins with the simplest extension of what we already know, the infinite continuation of space. If the cosmos stretches without end, then beyond the reach of our telescopes exist regions so far away that light has never had time to reach us. Those regions obey the same laws of physics, but their initial conditions differ. In that vastness, every possible arrangement of matter repeats somewhere. This level 1 multiverse is not strange at all. It is the natural result of an infinite universe governed by the same rules everywhere. The second level deepens the concept. It imagines universes not just separated by distance, but by difference. In the level 2 multiverse, inflation, the process that expands space, does not end uniformly. Different regions cool into separate universes with distinct constants, particles, and laws. Each bubble universe is a self-contained cosmos, born from the same inflationary field but crystallized under unique physical conditions. Some might contain stars made of exotic matter, others might lack chemistry altogether. This level describes a multiverse of variation, where nature experiments with every combination of physical possibility. The third level turns inward, to the quantum world. It is the many worlds interpretation, where every quantum event creates new branches of reality. This level 3 multiverse does not add new space, but multiplies the number of existing realities within the same quantum framework. Every time a choice or measurement occurs, the universe divides, spawning new paths that all remain real. Unlike level 1 and level 2, which depend on cosmic scale, level 3 operates at the smallest scales of probability, yet its reach is infinite. Together, the three levels describe a cosmos that expands outward, diversifies, and branches simultaneously, a vast garden of being growing in all directions. But Tegmark's most radical step lies in the fourth level, the mathematical multiverse. In this vision, reality itself is not physical, but mathematical. Every consistent mathematical structure exists as its own universe, governed by its own internal logic. The equations that describe our cosmos are not merely useful models, they are reality itself. Our universe exists because its mathematical form permits self-awareness, complexity, and time. Other mathematical structures may generate entirely different forms of existence, universes with unfamiliar dimensions, properties, or even concepts of causality. This final level blurs the line between physics and philosophy. If all mathematical structures exist, then every possible reality that can be described logically already exists, independent of observation or creation. There is no distinction between what is and what can be. Reality becomes an infinite library of mathematics, and our universe is one of its many books. The physical world we experience is simply the projection of one of those mathematical patterns into consciousness. The architecture of the multiverse, taken as a whole, forms a structure that climbs from the tangible to the abstract. Level I describes space as infinite repetition. Level 2 adds diversity in physical laws. Level 3 introduces the quantum branching of all possibilities. Level 4 expands reality into the totality of mathematics itself. Each level contains the previous, forming a pyramid of existence with abstraction at its peak. At that summit, the distinction between matter, energy, and thought dissolves into a single truth. Existence is the realization of mathematics. This layered view of reality reshapes the human place within it. If our universe is one among countless mathematical possibilities, then existence itself may not require cause or purpose. It simply is, because all that can exist does. Our experience becomes a self-aware subset of a larger mathematical truth, a fleeting but meaningful pattern within the infinite geometry of being. The multiversal architecture is not a map to be explored, but a philosophy of structure. It invites a kind of awe that blends logic with wonder. For those who contemplate it, there is a strange comfort in the idea that even if our universe fades, the underlying mathematics remains eternal. Somewhere, within the limitless landscape of possible forms, another version of existence will echo the same patterns, continuing the eternal expression of reality through number, symmetry, and possibility. Every theory, no matter how elegant, longs for proof. The multiverse, vast and unobservable by design, tests the very meaning of evidence. How can we confirm realities that exist beyond reach, separated by horizons of space, time, or dimension? The answer may lie not in what we can see directly, but in the faint imprints left behind the subtle fingerprints of other worlds upon our own. The first whisper of such evidence comes from the sky itself, the cosmic microwave background, that ancient radiation still humming across space, carries the memory of our universe's infancy. When satellites mapped it with exquisite precision, scientists noticed that the pattern of tiny temperature variations was almost, but not perfectly, random. A few peculiarities lingered: cold spots larger than expected, alignments that seemed too orderly. Some researchers wondered if these might be scars from beyond our universe, signs of collisions with neighboring bubbles in the multiversal sea. If two universes ever brushed against each other during their inflationary birth, the impact could leave a circular imprint, a faint bruise on the cosmic fabric. No such collision has been confirmed, but the search continues. Telescopes like the Planck Observatory have mapped the sky in detail finer than the human eye could ever perceive. Each new dataset is combed for patterns that defy explanation, for anything that hints at a reality pressing against our own. Though the results remain inconclusive, the very act of searching marks a profound shift. Scientists now look for evidence of the unseen, guided not by imagination, but by mathematics. Beyond the background radiation, quantum physics offers another kind of whisper. The behavior of particles often hints at influences we cannot trace. Some interpretations suggest that quantum fluctuations, the random popping of particles in and out of existence, may not be random at all, but manifestations of interactions across universes. Each fluctuation could be a small window through which our universe exchanges energy with its unseen neighbors. Though speculative, this idea connects the infinitesimal and the infinite, suggesting that every quantum tremor carries echoes of other realities. Dark matter and dark energy too haunt the question. They dominate our cosmos, yet remain invisible and mysterious. We detect them only through gravity, through the way galaxies move and light bends. What if their source lies beyond our universe? Some physicists propose that the gravitational pull we attribute to dark matter could come from matter existing in parallel dimensions, its influence leaking through the unseen structure of the multiverse. Others suggest that dark energy, the force accelerating cosmic expansion, may be the pressure exerted by neighboring universes pushing against ours. If so, the largest mystery in cosmology could be the touch of other worlds, gently reshaping our fate. Another strand of possible evidence lies in the fine-tuning of physical constants. The strength of gravity, the charge of the electron, the ratio of the universe's expansion to its density, all are set within impossibly narrow ranges that permit life. A slight deviation in any of them, and stars would not form, chemistry would not work, consciousness would not arise. The multiverse offers a natural explanation. If there are countless universes, each with its own laws, it is inevitable that some will have the right conditions for life. We live in one simply because only such universes can produce observers capable of asking the question. The precision of our universe becomes not coincidence, but consequence, the statistical inevitability of infinity. Yet, the multiverse defies the traditional standards of verification. It cannot be placed in a test tube, observed through a telescope, or recreated in a laboratory. The boundaries that separate us from other universes are not walls of matter, but limits of information. No signal can cross from one inflationary bubble to another. No experiment can measure beyond its own space-time. The evidence we seek must therefore be indirect patterns, probabilities, and anomalies that refuse to fit within a single universe model. This challenge forces science to confront its philosophical edge. Does something unobservable qualify as real? For centuries, physics has expanded its definition of reality to include entities first inferred, then detected, atoms, neutrinos, black holes. The multiverse may demand the same shift, a recognition that absence of direct contact does not imply non-existence. When mathematics and observation converge to point beyond the visible, perhaps that is evidence enough to listen. Some physicists argue that the multiverse is not a hypothesis, but a prediction, a consequence of existing, tested theories like inflation or quantum mechanics. If those theories are true, then the multiverse follows naturally. In that sense, proof of the multiverse may already exist, hidden within the equations that describe our universe's birth. Others counter that such reasoning risks drifting into metaphysics, where anything conceivable becomes real. Between these extremes lies a delicate balance, the pursuit of evidence that respects both the rigor of science and the vastness of imagination. The search for the unseen continues with new instruments and methods. Observatories scan the sky for gravitational waves, ripples that could carry signatures of events beyond our cosmic boundary. Particle accelerators probe energies that might hint at dimensions curled tighter than atoms. Each discovery, whether confirming or refuting, brings us closer to understanding what kind of reality we inhabit, singular or plural, finite or boundless. Perhaps the evidence we seek is not hidden in the sky or buried in equations, but written in the logic of existence itself. The universe does not appear random. It appears ordered, yet flexible enough to allow endless variation. That balance, fragile yet profound, may be the strongest hint of all that we are part of, something larger, a single thread woven into a fabric so vast that its total pattern will forever remain beyond touch. To look at the universe is to change it. The act of observation, so passive in daily life, becomes something profound when extended to the fabric of reality itself. In the world of quantum mechanics, to measure is to decide, to see is to create. This is the observer's paradox, the unsettling realization that consciousness, or at least observation, may not merely witness existence but help define it. In the smallest domains of physics, particles refuse to behave until observed. An electron hovers in a blur of probabilities, neither here nor there, until a detector forces it to choose. The universe, at its most fundamental level, seems to hold its breath, waiting for awareness to arrive. This notion is not metaphorical. It is encoded in the equations that describe how matter behaves. The wave function, a mathematical representation of possibility, collapses into a single outcome the moment it is measured. The observer's attention turns potential into reality. Such strangeness once seemed confined to the quantum world, but its implications ripple outward. If every particle obeys quantum law, then every object, every event, every mind is part of that same network of probabilities. The observer is not an external spectator standing outside the universe. The observer is within it, entangled with it. The boundaries between subject and object blur. The cosmos does not simply exist independently. It becomes through interaction. Some physicists and philosophers have dared to ask whether observation itself is fundamental, whether the universe requires awareness to manifest at all. This is not to claim that human consciousness alone sustains existence, but rather that the act of observation, in any form, is woven into the structure of reality. A detector measuring a photon, a molecule sensing another's vibration, a mind perceiving a star, all are expressions of the same process. The universe may, in a sense, observe itself through countless interactions, each collapsing uncertainty into form. In this view, the multiverse takes on a startling new meaning. If every quantum event splits reality into branches, then each observation determines not only what happens, but which universe we inhabit. Consciousness, by choosing one path from many, participates in the branching of worlds. Each observer, through attention, defines a distinct version of reality. The multiverse becomes a field of potential, and observation is the mechanism by which potential crystallizes into experience. The paradox deepens when we realize that the observer is also observed. The brain that perceives is itself a quantum system, its neurons firing through microscopic processes governed by the same uncertain laws. The mind, which seems to bring order to reality, is built from particles that obey chaos. Observation, then, becomes circular, the universe watching itself through patterns of energy that have learned to reflect. The act of perception is not one way. It is a feedback loop connecting consciousness and cosmos in an endless exchange. In the laboratory, this interplay appears as subtle interference patterns and probability waves. In life, it manifests as awareness, the ability to experience existence from the inside. Perhaps consciousness is not an anomaly of evolution, but a natural product of a self-aware universe. The same equations that describe collapsing wave functions may describe the emergence of mind. If so, every thought, every perception, is a small act of cosmic creation, shaping one corner of reality from the infinite tapestry of possibility. Yet, the observer's paradox also carries a quiet warning. If reality depends on observation, then truth itself becomes conditional. What is real for one observer may not be real for another. At the quantum level, different observers can record different outcomes, each consistent within their own frame, but incompatible when compared. The universe allows no single, objective snapshot. It is a mosaic of perspectives, each valid within its own branch. Certainty becomes local, truth plural. This idea challenges the foundation of science itself, which seeks objectivity, a reality independent of who observes it. But the paradox does not destroy objectivity, it refines it. It suggests that the universe's laws remain consistent, yet their outcomes vary across observers. The act of observation does not rewrite the rules, it selects which version of the rules we experience. In this way, science remains a map, one drawn from within the terrain it describes. There is a strange poetry in this entanglement between mind and cosmos. The same awareness that wonders about the universe may be the mechanism through which the universe knows itself. Observation becomes communion, a bridge between the finite and the infinite. When we gaze at the stars, we are not merely collecting light, we are participating in the story of existence, helping the cosmos see itself from within. The observer's paradox, then, is not a contradiction but an invitation. It asks us to see consciousness not as an accident of biology, but as a fundamental thread in the fabric of reality. It reminds us that knowledge is never separate from participation, that the universe is not a stage on which we stand, but a living system in which we belong. The moment we observe, we become part of the phenomenon. The universe, in turn, becomes part of us. To exist, perhaps, is to observe. To observe is to shape. And in that endless act of mutual becoming, the universe and its observers countless, scattered across infinite worlds, continue the quiet, eternal dialogue that makes reality what it is. Dreams reveal how effortlessly reality can be made and unmade. In the theatre of the mind, entire worlds arise in seconds. Landscapes unfold, time stretches or shrinks, and people appear who never existed. Within a dream, everything feels solid, inevitable, real. Only when we wake do we recognize the illusion. This small nightly miracle offers an uncanny reflection of the universe itself, a reminder that what we call reality may be another kind of dream, one shared by all conscious beings, sustained by laws we only partly understand. When physicists describe the quantum world, they often speak of probabilities, of existence suspended between possibilities, until measured. Dreams function in a similar way. They are not built from physical matter, but from patterns of information, emotional energy, and neural activity. The mind, in dreaming, acts as both creator and observer. It designs an environment and then lives within it, unaware of its own authorship. This is the same paradox scientists face when studying the cosmos. We are part of the system we observe, unable to stand outside it to see the full picture. In a dream, physical laws are malleable. Gravity loosens, logic bends, identities merge. The dreamer rarely questions this because the brain accepts the internal coherence of its own simulation. The universe operates on a grander scale, but with the same consistency. Its laws, from gravity to electromagnetism, provide coherence within its frame. To beings inside it, those laws seem absolute. But if multiple universes exist, each governed by its own rules, then our physical constants may be no more fundamental than the dream logic that holds a sleeping mind together. Each universe could be a self-consistent dream of existence, stable from within but different in the larger context of the multiverse. Dreams also reveal how meaning is constructed, not discovered. A mountain in a dream is not made of stone, it is made of thought, yet it carries emotional weight, a sense of presence. The universe, though made of matter and energy, shares this dual nature. It is not just structure, it is experience. Consciousness gives it texture and significance. Without observers, the cosmos would be silent, real perhaps, but unexpressed, like a dream with no dreamer to feel it. The analogy suggests that awareness and reality are intertwined, each giving the other form. Some philosophers and scientists have taken this comparison further, imagining that the universe might literally be a kind of dream, not of a single mind, but of mathematics, information, or the collective consciousness of all things. In this view, reality is a vast, self-consistent simulation, unfolding from the laws of physics, much as a dream unfolds from the neural patterns of the brain. Every galaxy, every life, every thought could be a momentary image within the greater dreaming of the cosmos. Yet the dream analogy is not meant to diminish reality. Dreams are not unreal, they are real experiences within a different domain. Their landscapes exist in neural activity, their emotions in measurable chemistry. Likewise, the universe may be real within its own framework, even if other frameworks exist beyond it. To call it a dream is not to deny its truth, but to recognize its layered nature, one level of reality nested within many. The similarity deepens when we consider time. In dreams, an entire narrative can unfold in what feels like hours but lasts only seconds. Time, there, is elastic, dependent on perception. Physicists studying relativity find that cosmic time behaves similarly. It stretches and contracts depending on motion and gravity. The flow of time is not uniform across the universe, and perhaps not across universes either. In both dreaming and cosmology, time is a dimension molded by experience and perspective, not an absolute current flowing from past to future. There is also the matter of awakening. When we wake from a dream, we enter a broader reality that includes the dream but also transcends it. The dream dissolves, but its memory remains. If our universe is itself one layer in a vast multiversal structure, then awakening might mean perceiving the next layer, a state of awareness that sees the connections between worlds rather than the boundaries. Death, in this metaphor, could be a form of waking, not an end, but a shift in awareness from one level of reality to another. Science may not frame the question in those terms, yet the pattern is irresistible. Just as the dreamer cannot see the neurons that generate the dream, we cannot yet perceive the deeper mechanisms that generate our universe. We experience the results, but not the source. The multiverse, in this light, becomes a cosmic mind, endlessly dreaming realities into being, each universe a thought that blooms and fades, while the total mind never sleeps. Perhaps that is what consciousness is, the reflection of the cosmos dreaming itself. Every act of perception, every spark of awareness, is a miniature awakening within the grander dream. When we look at the stars, we are fragments of that dream becoming self-aware, momentarily realizing that we are both the dreamers and the dream. The dream analogy reminds us that reality, no matter how solid it feels, may be deeper than perception. It asks us to approach existence not with certainty, but with wonder, to recognize that the boundaries between imagination and matter, thought and form, are thinner than they appear. Whether the universe is physical, mathematical, or dreamlike, it remains, at its heart, an unfolding of meaning. And meaning, as every dreamer knows, is the most real thing of all. Every light casts a shadow, and perhaps every universe does too. What we perceive as the complete cosmos may be only the illuminated side of existence, while its darker counterpart remains unseen. In the faint background of reality, invisible forces press against us, dark matter shaping galaxies, dark energy stretching space. These mysterious elements make up most of the universe, yet they emit no light, no signal, no sound. They are not merely absences, they are presences we cannot touch. Their silence may conceal more than missing physics, it may hint at the existence of shadow realities. Astronomers first noticed these shadows through motion. Galaxies spun too fast, stars at their edges moving as if held by invisible hands. According to known laws of gravity, such motion should have torn them apart. Something unseen was binding them together, that something, now called dark matter, outweighs ordinary matter 5 to 1. It is everywhere and nowhere, surrounding galaxies in vast halos, drifting through us, shaping the universe's structure. Yet no telescope, detector, or collider has ever caught a glimpse of it directly. Dark energy deepens the mystery. Instead of pulling matter together, it pushes everything apart. It drives the universe to expand faster with time, an effect discovered when scientists observed distant supernovae dimmer than expected. The source of this acceleration remains unknown. It behaves not like matter, but like the fabric of space itself, gaining energy as it stretches. Together, dark matter and dark energy compose roughly 95% of the cosmos. The stars, planets, and atoms we know form only the remaining sliver. In other words, almost everything that exists is invisible to us. The nature of that invisibility has inspired one of the most provocative possibilities in modern physics, that dark matter and dark energy might not be part of our universe at all, but evidence of other universes pressing against it. If our cosmos is a three-dimensional membrane floating in a higher dimensional bulk, as brane theories propose, then matter from a neighboring brane could exert gravitational influence across dimensions. The missing mass we sense as dark matter might be the shadow of galaxies in a parallel universe, their gravity leaking faintly into ours through the dimensional veil. In this vision, every universe casts a gravitational shadow onto its neighbors. Just as two translucent films of glass can distort each other's reflections when held close, overlapping universes could subtly warp each other's space-time. We might be feeling the contours of realities we can never see, an interdimensional topography where universes influence one another through gravity, even though their light can never cross the divide. Some researchers have searched for direct signs of such contact. If another universe brushed against ours early in cosmic history, the collision might have left an imprint, a ring-shaped pattern or temperature anomaly in the cosmic microwave background. These marks would be the scars of reality itself touching its twin. While no definitive evidence has yet been found, the possibility remains tantalizing. The cosmos may carry within its own radiation a memory of another world's existence. Beyond the physical lies a more abstract sense of shadow. In quantum theory, every particle carries an unseen partner state, a mirror of probability that exists but cannot be measured. The wave function describes both the real and the potential, yet we experience only one outcome. The others, the unchosen paths, the silent possibilities, become the shadows of reality, existing in superposition until observation divides them. Each choice we make leaves countless shadow versions of ourselves, moving unseen through parallel worlds. These shadow realities may be as close as our breath and as unreachable as infinity. They suggest that what we call reality is only one layer of a deeper structure, one strand in a tapestry woven of both visible and invisible threads. Dark matter might be the physical expression of that hidden weave, quantum possibility, its conceptual reflection. Together, they hint that the cosmos is not a singular existence, but a composite, its visible face resting upon a vast, unseen foundation. Even in philosophy and myth, shadows have long symbolized the unknown counterpart of being. They represent what cannot be illuminated, what resists full understanding. In this sense, dark matter and the unseen universes, it suggests, may be the modern incarnation of an ancient truth, that existence always contains more than what is seen. The light of understanding can reveal only so much before it meets the horizon of mystery. Beyond that horizon, the shadows remain not as emptiness, but as possibility. Contemplating these hidden worlds changes how we see our own. Every star, every movement of gravity, may carry the silent influence of another reality intertwined with ours. The air between galaxies is not empty. It trembles with unseen presence. We are not floating in isolation, but surrounded by shadows that shape our every motion. The universe we know is a single visible edge of a much larger, darker whole. Perhaps the shadow realities are not meant to be solved, but recognized as reminders that mystery itself is part of existence. Without darkness, there is no depth. Without the unseen, there is no perspective. The cosmos, in all its brilliance, is balanced by its hidden counterpart. The visible universe is the light of the candle, the multiverse, its infinite shadow cast upon the wall of the unknown. The universe appears steady and predictable, yet it balances on the sharpest of edges. Every law, every particle, every interaction depends on a set of physical constants, unchanging numbers that define the structure of reality. The strength of gravity, the speed of light, the mass of the electron, the ratio between forces, all of these values are finely tuned. Shift any one of them even slightly, and the universe as we know it collapses. This delicate precision has long puzzled scientists and philosophers alike. Why do the constants have the values they do? And what would happen if they were even minutely different? Imagine gravity, that quiet sculptor of the cosmos. Its strength is astonishingly small compared to the other forces. Increase it by a fraction, and stars would burn too quickly, collapsing into black holes before life could emerge. Weaken it, and matter would drift apart. Galaxies, planets, and life itself would never form. The balance is perfect, not by design we can prove, but by necessity. It is the narrow range that allows complexity to exist at all. The same fragile precision applies to the electromagnetic force. It holds atoms together, binds electrons to nuclei, and governs the chemistry that makes life possible. Alter its strength just slightly, and atoms could not form stable molecules. The strong nuclear force, which glues protons and neutrons inside atomic nuclei, must also be exact. Too weak, and hydrogen would be the only element. Too strong, and stars would never forge carbon or oxygen. The weak nuclear force controls the rate at which stars burn. If it differed by a small fraction, the universe would either freeze in darkness or explode in unrelenting brilliance. Even the speed of light plays a role in this fragile balance. It links space and time, setting the rhythm for causality itself. A faster or slower light speed would ripple through every equation, altering the structure of matter and energy. The cosmological constant, the parameter that drives the acceleration of the universe's expansion, is perhaps the most delicate of all. Its measured value is so improbably small that if it were larger by the tiniest margin, space would have torn itself apart long before galaxies could form. Physicists call this puzzle the fine-tuning problem. It is not simply that the constants appear perfect for life, it is that they seem almost too perfect. The odds of them falling within such life-permitting ranges, if chosen at random, appear astronomically low. Some see in this precision the hand of purpose, a sign that the universe is designed with intent. Others find a different explanation in the multiverse. If there are countless universes, each with different constants, then our world's improbable conditions cease to be surprising. In an infinite set of realities, every possible combination of laws exists somewhere. Most of those universes would be sterile, chaotic, or short-lived. A few, by chance, would fall within the narrow band that allows stars, chemistry, and observers. We find ourselves in one of those because we could not exist anywhere else. This reasoning, known as the anthropic principle, does not solve the mystery, it reframes it. The universe is not special because it was made for life. Life arises where the universe happens to allow it. This view may feel unsatisfying, yet it resonates with the logic of probability. Just as every sand grain on a beach differs in shape, every universe in the multiverse could differ in its laws. We stand on one grain among infinite others, not because it was chosen, but because it is where consciousness found footing. The fragility of constants, then, becomes a sign not of exclusivity, but of abundance. Still, the elegance of this balance evokes wonder. Every heartbeat, every sunrise, every thought depends on numbers that never vary. Even the smallest fraction of change in these constants would erase the possibility of beauty, meaning, or existence. The universe is an equation balanced on a knife's edge, where chaos and order meet in fragile harmony. Some scientists propose that these constants may not be constant at all, that over cosmic timescales, they might drift subtly, reshaping the fabric of reality in slow motion. Others suggest that the constants emerge from deeper laws still undiscovered, mere reflections of a more fundamental framework. If so, our universe's apparent precision might be the result of deeper symmetries, hidden beneath the surface of what we can measure. Whether by chance, necessity, or design, the constants remind us that existence is precarious. The cosmos does not need to permit life, yet somehow it does. It balances the fierce forces of creation and destruction in perfect proportion, allowing complexity to emerge from simplicity. The more deeply we study these numbers, the more they appear not arbitrary but exquisite, as if the universe were composed not only of matter and energy but of meaning itself. Perhaps the constants are not fixed, but chosen anew in every universe that forms. Each reality could represent a different solution to the same eternal equation, its constants setting the tone of its cosmic symphony. Some songs would be brief and discordant, others long and harmonious. Ours happens to play a melody that includes us fragile listeners in an infinite concert of possibility. The fragile constants are a reminder that existence is both improbable and inevitable. In the vastness of all potential universes, one must allow life. We inhabit that narrow sliver of possibility, balanced delicately between chaos and void. Every constant, every law, every number hums in harmony, and from that harmony arises everything we know: the stars, the atoms, the awareness to marvel at the precision that made them possible. There is a quiet unease that lingers at the edge of modern thought, a suspicion that reality itself might not be what it seems. The laws of physics behave with such perfect consistency. The universe so neatly follows patterns of information that some wonder if existence could be more like computation than creation. The simulation hypothesis suggests that our universe might be an artificial construct, a simulation running on unimaginable machinery, coded by intelligence far beyond our own. At first glance, the idea sounds like science fiction, yet its logic arises naturally from both mathematics and technology. Every day, humans build digital worlds that grow more sophisticated. Computer simulations already model weather systems, ecosystems, and even galaxies. Virtual reality allows people to inhabit fully realized environments, indistinguishable, in some aspects, from physical space. As computational power advances, these simulations become more detailed, more responsive, more real. If such progress continues, there will come a point when entire civilizations could be simulated, complete with conscious beings who believe themselves real. From there, philosopher Nick Bostrom offered a startling argument. He proposed that if it is possible to simulate conscious beings, and if advanced civilizations eventually do so, then the number of simulated universes would vastly outnumber the single base reality. Therefore, statistically speaking, it is more likely that we live inside one of these simulations than in the original physical universe. It is a probabilistic twist that transforms the question of "could it be true?" into "how could it not be?" This reasoning raises deeper questions about what it means to exist. If the universe is a simulation, then the constants and laws of physics are not inherent features but programmed parameters. The quantum foam, the speed of light, the gravitational constant all could be lines of code in a vast algorithm governing our cosmic experience. Quantum uncertainty might even be a feature of this computation, a natural consequence of limited resolution in the simulation's data. What we interpret as randomness could be the rounding errors of a digital cosmos. Some scientists find curious echoes of this notion within physics itself. Reality, at its smallest scales, behaves as though it is quantized, divided into discrete packets of energy and space. The Planck length represents the smallest measurable distance, as though space were made of pixels too fine to detect. Information theory suggests that the universe's total information content is finite, bounded by its surface area, not its volume. Black hole thermodynamics even reveals that information cannot be destroyed, only rearranged. Such discoveries hint that the universe behaves like a system processing data, as though the cosmos were not continuous but computational. If this is true, then perhaps every particle, every photon, every field is part of an immense calculation unfolding across cosmic time. The galaxies are patterns of code. The vacuum is memory space. The laws of physics are the operating system. Consciousness itself might be the program's most complex output, a self-reflective process that allows the simulation to observe itself. Our sense of free will could be an emergent property of code that has learned to rewrite parts of its own script. The simulation hypothesis also provides a curious explanation for fine-tuning. If a universe can be simulated, its parameters can be adjusted. A designer, whether alien, artificial, or beyond comprehension could tune the constants of nature to support complexity, beauty, and awareness. In this view, the delicate balance of forces that allows life to exist might not be coincidence but calibration. The universe could be a grand experiment, a study in creation, or even an art form, a digital cathedral built from mathematics and light. Yet even if the idea were true, could we ever prove it? Some researchers have suggested looking for computational artifacts, limits in cosmic rays' energy spectra, or irregularities in space-time that reveal the grid beneath the illusion. Others search for anomalies in quantum entanglement, seeking signs that information transfer might be constrained by hidden rules. But if the simulation is perfect, its creators would design it to be undetectable. Like characters in a film, we could only infer our artificiality through subtle inconsistencies, never through direct observation. Still, the simulation hypothesis holds a peculiar philosophical weight. If reality is simulated, it does not make it less real to those within it. Our emotions, discoveries, and relationships would remain authentic experiences inside the system. Pain would still hurt, love would still matter. Even if the stars are pixels and gravity is code, meaning remains real, it exists wherever awareness finds it. The difference lies not in existence but in origin, and if the universe is simulated, what lies beyond it? Perhaps other simulations, stacked infinitely like Russian dolls, each one birthing countless others. In such a hierarchy, the base reality might be unreachable, buried beneath endless layers of computation. The multiverse could itself be a network of simulations, each differing slightly in their rules, their constants, their histories. Every simulated universe could spawn its own, as consciousness evolves and creates a new and infinite recursion of creators and creations. The simulation hypothesis merges science, philosophy, and myth into a single idea that creation may be self-perpetuating, awareness endlessly recreating itself through information. Whether we are coded or born, real or rendered, the awe we feel before the night sky remains unchanged. For even if the cosmos is an elaborate illusion, it is an illusion vast enough to contain love, thought, and wonder, a masterpiece of being that transcends the question of who or what built it. Every inquiry into the multiverse eventually folds back toward the same question: what in all of this is us? If there are infinite worlds, infinite versions of every moment, then the boundaries that define selfhood begin to blur. The individual, once considered the center of experience, becomes a pattern spread across realities, an awareness mirrored endlessly in the cosmic hall of possibility. The multiverse forces us to reconsider identity itself, not as a fixed point in space and time, but as a thread woven through the fabric of existence. The idea that the self extends beyond its physical limits is ancient. Mystics and philosophers have long sensed that consciousness is not contained by the body, that the mind participates in something vast and continuous. Modern cosmology gives that intuition a new language. If infinite universes exist, then somewhere every possible version of you is alive, the one who made a different choice, the one who was born elsewhere, the one who never existed at all. Together they form a constellation of selves, each a star in the greater identity of being. In this light, the self is not singular but multiversal. You are not one consciousness observing the universe. You are countless consciousnesses experiencing different aspects of it simultaneously. Each version feels alone and complete, unaware of its reflections elsewhere, yet all share a common root, the same initial pattern of potential, expressed through variation. Identity, then, is not destroyed by multiplicity, it is enriched by it. Every possible life becomes part of your total being, every timeline another brushstroke in the portrait of the cosmic self. This perspective transforms how we think about free will. In one sense, choice remains real, each decision branches the universe, carving new paths through possibility. But in another sense, every choice is already made somewhere, each path exists, each outcome unfolds. Free will, then, is not about creating new possibilities, but about experiencing one of them intimately. You are the awareness that rides the wave of a single branch, while infinite others unfold beside you. The self's journey is both a selection and a participation, an exploration of one possibility out of eternity's endless supply. Such thinking invites humility. The ego, which clings to uniqueness, dissolves before the immensity of this view. Yet in that dissolution lies liberation. To see oneself as part of a vast continuum is to feel connected to all things. Your joys and sorrows are no longer solitary events, but notes in the cosmic symphony. The same consciousness that looks out through your eyes may look out through others across countless worlds. In that sense, every being, human, alien, or otherwise, may be an expression of a single underlying awareness, learning itself through difference. Physics, too, hints at this unity. Quantum entanglement shows that separate particles can share a single state, acting as if distance does not exist. Consciousness might operate similarly, entangled across dimensions of experience we cannot measure. Just as two photons remain connected beyond space, perhaps minds across universes are facets of one awareness distributed through reality. The cosmic self would then be not metaphor but structure, the hidden coherence behind the seeming separation of individuals. If such unity exists, it reframes death as well. The end of a single life would not be annihilation but transition, the closing of one expression among infinite others. Somewhere, other versions of you continue in alternate histories, in quantum branches, in dreams yet unimagined. The awareness you experience now may reappear elsewhere, carried by the same fundamental consciousness that underlies all worlds. The cosmic self, in this sense, cannot die. It only shifts focus, endlessly reawakening in different forms. This idea is not about personal immortality in a sentimental sense, but about participation in something eternal. Each individual consciousness is a temporary interface through which the cosmos perceives itself. The universe, vast and indifferent, becomes intimate through you. Every moment of awareness, a glance, a thought, a heartbeat, is the cosmos recognizing its own existence from within. You are not separate from the universe. You are the universe, briefly self-aware. The multiverse magnifies this truth. If reality contains infinite variations, then every possible form of self-awareness exists somewhere. Each consciousness contributes to the total awareness of being. The cosmic self, then, is not a god above creation but the living sum of all observers within it. Through their eyes, the universe watches itself unfold. Through their minds, it contemplates its own patterns. The act of being conscious becomes the bridge between existence and meaning. In a way, the cosmic self is the final reconciliation of science and spirituality. Science seeks the objective laws of the universe. Spirituality seeks the subjective experience of unity. The multiverse shows that both pursuits may describe the same reality from different sides. The laws of physics generate structure. Consciousness gives it significance. Together, they form a complete circuit, the universe creating observers to witness itself, and observers giving the universe purpose through awareness. To contemplate this is to feel both infinitesimal and infinite. You are one among countless beings, yet inseparable from the totality that contains them. Every life, every reality, is a note in the same eternal song. When you look inward, you find the cosmos gazing back. When you look outward, you see your own reflection in the stars. The cosmic self is not a belief, but an awakening. The recognition that identity, like the universe, is boundless. You are not confined to the body, the planet, or the timeline you inhabit. You are a field of consciousness extending through every world that ever was or could be. To know this is not to lose individuality, but to understand it as one expression of the infinite, a single flame in the eternal fire of being, burning brightly for a moment, illuminating the mystery of itself. Every frontier in science eventually meets a horizon, a boundary where measurement falters and certainty dissolves. The multiverse rests precisely on that edge. It is a theory born from mathematics and logic, sustained by inference, and limited by the very nature of observation. It asks us to peer beyond the visible cosmos, yet it also warns that beyond a certain point, the light of knowledge cannot reach. The edge of knowing is where discovery becomes reflection, where the universe invites humility rather than mastery. For centuries, human progress has been defined by the expansion of what can be known. Each time we reached a limit, we pushed it back. Telescopes revealed galaxies beyond imagination. Microscopes uncovered worlds within worlds, equations turned chaos into order. Yet the multiverse challenges that tradition. It describes realities that cannot, by definition, be observed. The boundaries between universes are not walls of matter but limits of information. No signal can cross them. No experiment can confirm them. In confronting the multiverse, science faces the mirror of its own methods. This does not mean the search is futile. The pursuit of the unseen has always driven understanding forward. Before atoms were seen, their existence was inferred through patterns. Before black holes were imaged, they were known through mathematics and light silence. Perhaps the multiverse, too, will leave traces, gravitational ripples, quantum irregularities, or statistical fingerprints buried in cosmic radiation. But even if such hints emerge, direct confirmation may remain forever beyond reach. The very structure of reality might prevent its complete revelation. The edge of knowing is not a failure of science, but its continuation into mystery. It reminds us that knowledge is not only about answers, but about awareness of limits. The universe may not be built to be fully knowable. It may be an open system of infinite depth, where every explanation reveals deeper questions. The multiverse embodies that endless recursion, a cosmos that contains not one truth, but every possible truth, unfolding in parallel. To understand such a reality, one must accept that comprehension will never be total. Philosophically, this edge transforms knowledge from conquest into participation. The observer is not an outsider dissecting reality, but part of the same process being studied. To know the universe is to know ourselves within it, finite minds reaching toward the infinite, aware that the act of reaching is itself meaningful. The multiverse, whether real or imagined, becomes a symbol of this relationship. The tension between curiosity and mystery, between the known and the unknowable. Some scientists argue that theories beyond verification belong to philosophy, not physics, yet the border between the two has always been porous. The great revolutions of science, relativity, quantum mechanics, cosmology began as acts of imagination that stretched beyond current evidence. The multiverse may be another such leap. Even if it remains untestable for now, it widens our intellectual horizon, forcing us to consider that our universe is not the whole of reality, but one expression of a greater totality. In that sense, it is less a claim than an attitude, an acknowledgement that creation exceeds comprehension. Standing at this edge, we glimpse the humility inherent in knowledge. The more we understand, the more we realize how much remains hidden. Each discovery enlarges both our wisdom and our ignorance. The multiverse, infinite and unreachable, reflects this duality perfectly. It is both a scientific model and a metaphor, a reminder that truth may not be singular, that reality may not be reducible to one narrative. For the human spirit, the edge of knowing is both challenge and comfort. It tells us that curiosity has no ceiling, that mystery will always remain to inspire wonder. It also assures us that our limits are part of a larger balance. If we could know everything, the universe would lose its depth. Existence would become mechanical, predictable, lifeless. Mystery is not the enemy of knowledge, it is its source. The dark beyond the stars is not emptiness but invitation. The edge is also personal. Each person carries an internal horizon where understanding fades into awe. It is the point where reason gives way to silence, where thought meets the ineffable. Contemplating the multiverse brings us to that threshold, reminding us that reality's ultimate nature might be forever beyond articulation. Yet the very act of contemplating it is a triumph of consciousness, proof that the universe has evolved beings capable of imagining what they can never fully grasp. Perhaps that is the true meaning of the edge of knowing, not despair at what cannot be proven, but gratitude for the capacity to ask. The multiverse may remain beyond our reach, yet its possibility enriches every question we pose. It teaches us that knowledge is not a destination, but a journey through wonder, a path illuminated as much by what we do not know as by what we discover. To stand at this edge is to face the infinite with open eyes, accepting that understanding and mystery coexist as partners in creation. Beyond this horizon lies silence, not emptiness, but potential. The universe does not end there, only our comprehension does, and that perhaps is as it should be. For in the vast space between what is known and what can never be known, the human mind finds its truest place, small, curious, and filled with awe at the endlessness of being. Time feels like a river flowing forward, yet many thinkers have wondered if it might be a circle, instead, a current that bends back upon itself, carrying everything to where it began. The idea of eternal return imagines that existence does not move toward an end, but endlessly renews itself. Every atom, every life, every universe repeats in infinite cycles. What feels like progress may simply be recurrence. What we call history may be a single note resonating forever through the cosmic symphony. The notion is ancient, reaching back to early philosophers who sensed that creation and destruction are not opposites, but phases of one eternal motion. The Stoics believed that the cosmos was periodically consumed in fire, only to be born again in identical form. In Hindu cosmology, universes arise and dissolve in rhythmic ages called kalpas, vast epochs of creation, preservation, and dissolution. Even in modern physics, echoes of this cyclic vision reappear. Cosmological models describe universes that expand, contract, and rebound, or multiverses where every end becomes a beginning elsewhere. The eternal return can be understood in several ways. In one sense, it is a literal cosmology. If time and energy are infinite, then every configuration of matter must reoccur. Given enough duration, the universe will eventually reassemble every pattern, galaxies, species, individuals exactly as before. Somewhere in the immeasurable future, you may sit here again, reading these same words, unaware that the moment has already happened countless times. In another sense, eternal return is symbolic. It represents the continuity of existence, the unbroken cycle through which reality constantly renews itself. This vision transforms how we view impermanence. Death, decay, and entropy lose their finality when seen as part of an eternal rhythm. Every ending becomes the seed of a new beginning. The atoms that compose your body were once parts of ancient stars. The energy that fuels your thoughts has moved through countless forms. The universe itself may be participating in this same rhythm, expanding from a big bang, cooling towards stillness, and one day collapsing into a new singularity to begin again. If so, time is not an arrow but a breath. The cosmos inhales and exhales eternally. Quantum mechanics also hints at recurrence on smaller scales. The probability wave that defines reality can, in theory, explore every possible state given infinite time. Eventually, those probabilities must repeat. Statistical physics supports a similar idea. In a finite system with infinite duration, all configurations eventually recur. This is known as Poincaré recurrence, a mathematical assurance that everything returns if given enough time. The eternal return is thus not merely myth, but a consequence of the universe's own logic. Yet, the deeper meaning of this idea is not scientific but existential. To imagine eternal recurrence is to face the weight of infinite repetition. The philosopher Friedrich Nietzsche asked whether one could affirm life so fully that one would choose to live it again and again, eternally, in exactly the same way. The question is not about cosmology but courage. Could we embrace existence, with all its joys and sorrows, as something worth reliving forever? In that challenge lies a test of the human spirit to say yes to the totality of life, not just its comforts. From another angle, eternal return offers comfort. If existence repeats endlessly, nothing is truly lost. Every moment, every love, every beauty returns. Even the briefest joy becomes eternal through recurrence. In an infinite universe, every possibility must unfold again, ensuring that meaning is never erased. The cycle preserves all things, weaving memory and matter into a pattern that cannot be destroyed, only renewed. But recurrence also changes how we understand choice. If everything repeats, can there still be freedom? Perhaps freedom is not about altering destiny, but about the awareness with which we live it. Even if each act has happened before, consciousness makes it new each time. Awareness transforms repetition into creation. To live deliberately is to participate in eternity, to turn recurrence into affirmation. The idea extends beyond individuals to the cosmos itself. In a multiverse of infinite possibilities, every configuration of reality reappears. Universes may bloom, fade, and bloom again in endless variations, their differences repeating like themes in an infinite composition. The eternal return, seen through this lens, is not the monotony of sameness but the vitality of perpetual renewal, the universe learning, playing, and reshaping itself without end. For the human mind, eternity is almost unbearable to imagine, yet the eternal return softens that infinity by giving it rhythm. Instead of a vast, cold expanse, reality becomes cyclical, intimate, breathing. Every heartbeat, every orbit of a planet, every rotation of a galaxy echoes that cosmic pulse. The same energy that drives the stars courses through us, linking the smallest life to the largest structures. To exist is to participate in the universe's heartbeat. Ultimately, the eternal return reminds us that nothing truly passes away. Existence is conserved, transformed, and reappearing. The light of extinguished stars becomes the atoms of new suns. The end of one universe becomes the dawn of another. Even memory, though fleeting in one form, may echo endlessly across the dimensions of being. Life does not vanish, it circulates. Whether literal truth or profound metaphor, the eternal return is a call to presence. If everything repeats, then each moment matters infinitely. Every act, every word, every kindness is not a single event but an eternal gesture. To live fully, with awareness and gratitude, is to align oneself with the rhythm of creation. The universe may spin endlessly, but meaning exists wherever consciousness says yes to its own recurrence. At the edge of all theories beyond physics, philosophy, and faith, the eternal return stands as both question and answer, creation without beginning, existence without end. It invites us to imagine a reality where time is not a line but a circle, where life is not fleeting but everlasting in its repetition, and where every breath we take reverberates forever through the infinite cycles of being. There comes a point when even imagination falls quiet. After every equation has been written, every theory proposed, and every universe conceived, what remains is not another explanation but a stillness, the silence beyond all worlds. It is a silence that does not signal absence but completion, as though the act of asking has itself fulfilled its purpose. When thought reaches its outermost horizon, it meets the infinite not with answers but with awe. The multiverse, vast as it is, may only be one veil among countless others. Beyond it might exist dimensions or realities we cannot name, forms of being for which even the word existence is inadequate. There may be no boundary, no final layer, only endless unfolding. Yet beyond the unfolding lies something subtler still, the quiet awareness that witnesses it all, the presence that remains when the mind lets go of trying to know. Every culture has intuited this silence in its own way. Ancient mystics called it the void, the Tao, the ineffable source. Philosophers named it the ground of being. Physicists, tracing equations back toward the beginning of time, approach it as a singularity, a point where all distinctions dissolve. The language changes, but the experience is the same. A frontier where thought ceases and wonder begins. The silence beyond all worlds is not a blank nothingness, but a fullness so complete that it needs no form. In this stillness, opposites lose meaning. Creation and destruction, light and darkness, self and cosmos, all merge into a single presence. The multiverse, with its infinite variations and branching possibilities, is like a shimmering surface on that deeper ocean. Every universe, every life, is a ripple on that boundless sea, born from its stillness and returning to it in time. The silence is not separate from creation. It is the medium through which creation happens, the timeless background that allows time to flow. Human language struggles here. Words are tools of distinction, but this realm is beyond distinction. To describe it is to limit it, and yet silence alone feels too small. It is more like an awareness that contains all opposites, existence and non-existence, motion and rest, knowing and unknowing. It is the space between thoughts, the breath before the universe exhales another world into being. It is not something we reach by traveling outward, but by turning inward toward the still point at the center of consciousness. In the hush between heartbeats, we sometimes glimpse it. It is the feeling that arises when standing beneath a sky so vast that it erases thought when hearing the ocean at night, or when realizing that the light of a star left its source before life began. These moments of silence are the edges of understanding, the faint reflections of that greater quiet. They remind us that beyond all knowledge lies something greater than knowledge, not ignorance, but presence. Perhaps this silence is the true multiverse, the origin from which every possibility arises. If every universe is a word, the silence is the language that gives them meaning. Each world is an expression, a vibration in the stillness. When a universe ends, it does not vanish. It returns to that silence, waiting to be spoken again in another form. The cycles of creation and dissolution are not battles between being and nothingness, but movements within the same eternal calm. Science may never measure this stillness, yet it is the background against which all science unfolds. Every discovery, every revelation, every equation is a temporary spark within it. To sense that is not to abandon reason, but to complete it, to realize that understanding is only one mode of participating in reality. Silence is another. Where reason dissects, silence embraces. Where knowledge describes, silence experiences. Both are ways the cosmos knows itself. In the end, the silence beyond all worlds is not something distant. It is here, now, within every moment of awareness. Beneath thought, beneath sensation, beneath even the perception of time, it is always present, the unchanging stillness through which everything else moves. It is the one constant that needs no equation, the background against which universes bloom and fade like breath. To encounter it is not to escape the world, but to see the world as part of something immeasurable. The stars, the galaxies, the countless universes of the multiverse all shimmer briefly upon the surface of this infinite quiet. The silence does not oppose them, it gives them meaning. It is the ultimate symmetry, the perfect equilibrium where creation and rest are the same. Perhaps this is what every question ultimately seeks, not an answer, but return. To the mind, it is mystery. To the heart, it is peace. Beyond all worlds, beyond even the idea of infinity, lies that vast stillness from which all things emerge and to which all things will someday return. The multiverse may be endless, but silence is eternal. It is the breath before creation, the pause after time, the final truth that requires no words at all. End of the most mind-bending facts about the multiverse. Sleep to infinite worlds.